Let's look at this problem together. In how many ways can the sequence 1, 2, 3, 4, 5 be rearranged so that no 3 consecutive terms are increasing and no 3 consecutive terms are decreasing? The first impression of this problem is the statement itself is fairly simple because we are just to rearrange 5 numbers, 1, 2, 3, 4, 5. However, after some careful thought, you'll find out that it's not quite easy to do the counting. The basic issue about that is that no standard mathematical models or formulas can be applied to this problem directly. Therefore, we have to examine the cases and see what patterns can we find. Alright, let's get started. Suppose we have 5 numbers. Right? These are the 5 numbers, and we want to place 1 to 5 in these 5 places. Let's suppose we do have 3 consecutive increasing numbers. Then what does it look like? For example, the first 3 numbers are increasing. Then it must be something like this. The second is greater than the first, and the third is greater than the second. Right? Or in the other way, we have 3 consecutive decreasing numbers. Let's say the middle 3 are decreasing. Then from the second to the third, it has to be decreasing. And the next, the fourth, has to be smaller than the third. Therefore, you probably have seen this pattern. When we do have consecutive increasing or decreasing numbers, we have these consecutive increasing or decreasing signs. Then let's look at the flip side of this coin. I'll clean up the signs a little bit. Let's look at the flip side. When we do not have 3 consecutive numbers that are increasing or decreasing, then that means when we increase between the first 2 numbers, we have to decrease in the next place, and then increase again, and then decrease again. Right? Or when we decrease from the first to second, we have to increase and then decrease and then increase. Therefore, this tells us that for all the legitimate arrangements of these 5 numbers, the increase or decrease signs have to be alternate. So now let's put this down. This is the pattern that we've found. Right? So the pattern is that the increasing and decreasing signs have to be alternate. And by symmetry, we know that the number of ways that we can rearrange the 5 numbers in these 2 patterns shall be equal. Therefore, let's call this case 1 and this case 2. This is a very natural standard that we can split this problem into 2 easier scenarios. And then we only need to focus on one of the 2 cases. Let's say we only focus on the first case. And after that, remember, we need to multiply a 2. Right? That represents we have 2 symmetric cases. However, even if we know that the numbers are increasing, decreasing, increasing, and decreasing, right? We know this pattern, but we are still not quite clear how these 5 numbers can be placed into these 5 places. We have to give it a try and try some specific cases, and then see if we can find some furthermore patterns. Alright, since the first number is smaller than the second number, let's start from something smaller. Let's say we have 1 in the first place. Then the second number can be a lot larger or slightly larger. Let's try both scenarios. First, let's assume the second number is a lot larger. Let's say 4 or 5, right? So we put a 4 here. Then the middle number can be 2 or 3. It doesn't matter what you put there. Let's say we put 3 here. And then the next number has to be 5. Otherwise, If you put a 2 here, we have a decreasing pattern, right? So this has to be 5, and then 2 in the last place. In the next scenario, we have 1 in the first place, and then a slightly larger number in the second place. So let's try 2 or 3. Let's try 3 first. If it is 3, then the third place has to be 2, right? And then the next place, the fourth place, has to be 5. Because if you have 4 here and the 5 in the last place, again, we have an increasing sequence. Therefore, we put a 5 here and the 4 in the last place. Then let's try a third scenario. We have a 1 and we have a 2 in the second place. Then immediately we find a problem. No matter what we put in the third place, we have an increasing sequence, right? Because 1 and 2 are the smallest two numbers. Therefore, this is impossible. Now let's try some other cases. Let's say we put a 2 in the first place. Then the second number got to be something larger, right? So again, let's try something really large. Let's say 5. Then the middle number can be either of 1 or 3, right? But it can't be 4. If you put a 4 in the middle, then no matter what you put in the fourth place, you have a decreasing sequence. You have a 4 here, you have a whatever number in the fourth place that's decreasing. Therefore, the middle number got to be 1 or 3. So let's try 3. And then the next number got to be 4, right? And the last number is 1. All right, let's do a little cleanup. So let's still look at the first number. If the first number is a 2, can the second number be just a little bit larger than 2? Let's say 3. And then the third number is 1, right? The next number have to be 5, and then 4 in the last place. If we flip 4 and 5, we will have 1, 4, 5. That's an increasing sequence. Therefore, this is the only possible case. So from all the analysis here, some of you may have probably find certain patterns. For example, when numbers can fit into the first place, you can certainly start your counting in that way. So what numbers fit first place? This is one pattern. Another pattern can be what number fit the third place. Because from the analysis, we find that many numbers don't fit the third place or the middle place. So what number fit the middle place? And there are actually a lot more patterns. For example, where can we place 5? Right? Where to place 5? That's the largest number we have. So we only have limited of place that this 5 can be placed. Or we can think about where can we place 1? Where to place the number 1? So there are many similar patterns that you can find to start your counting. And in here, we'll take a different approach. Let's look at the second column and the fourth column. Do you find any patterns? I think you do, right? These two places have to be a big number, either 3, 4, or 5. You can't place a 2 or 1 in these two places. So this is our conjecture. We need to justify that. Let's suppose we have 2 in the second place, and then the first place got to be 1. And this is certainly wrong, because no matter what we put in the third place, we have an increasing sequence. Therefore, this is wrong. And if we have 1 in the second place, then we got a contradiction already, right? We have no smaller number to be placed in the first place. Therefore, this is also wrong. Then we know that our conjecture is correct. These two cases are wrong. Let's put it down. So we find some further patterns. This pattern is only 3, 4, or 5 at the second and fourth place. And now we can split the problem into even finer subcases. So that will be, we have 4 and 5 at second and fourth place. Or we have 3 and 5. Or we have 3 and 4 at these two places. Now we can check them one by one. But before that, I want to point out that the reason I'm suggesting this approach doesn't mean this is the only way or this is the best way. It is only because that I find this way to be a reasonably fast approach. But it may not be the fastest approach. Therefore, I do recommend all students to try the different patterns, like the examples I put in here. And there are maybe some other patterns that you find. All right, let's start the counting. So for 4 and 5 at the second and the fourth place, then we have two possibilities, either 4 and 5 or 5 and 4. So that's 2 times. Once these two largest numbers are fixed, 4 and 5 are fixed at the second and the fourth, then we can place the other 3 small numbers randomly in the rest of the 3 places. And that will be 3 factorial. We can think of 4 and 5 as 2 separators. Then they separate the 3 smaller numbers. So in either case, we are good. Now let's look at the second subcase, 3 and 5 at the second and the fourth place. Again, we have 2 ways to place 3 and 5. We have 3, 5 or 5, 3, right? So that's 2 ways. And then multiply. Let's scroll down a little bit. Now if we have 3 and 5 in these 2 places, we need to consider where to put 4. Can we put 4 in the middle? If 4 is in the middle, no matter what we put in the first place, we have an increasing sequence. And the same thing for 4 in the first place, right? Then we form a decreasing sequence. Therefore, 4 cannot be around the number 3. It has to be on the other side of 5. So we have one place to put 4. 4 has to be next to 5. Then for the rest of the 2 small numbers, 1 and 2, we can simply permute them and place them randomly in the rest of the 2 places. Therefore, we have 2 factorial. Then let's look at the last subcase, 3 and 4. And we will see that this is virtually impossible, because if you have 3 and 4 in these 2 cases, where shall we put 5? If 5 is in the middle, then this is a decreasing sequence, right? If 5 is here, this is an increasing sequence. Or 5 is here, then this is decreasing sequence, right? Therefore, 3 and 4 are impossible. Up to now, we are pretty much done with our counting. So now let's collect the terms. We have 2 times 3 factorial plus 2 times 1 times 2 factorial, right? And don't forget, we need to multiply a 2, because this is only for our case 1, this case 1. And we need to multiply this 2. That's over here. Look at the upper right corner. We have 2 symmetric cases. Then let's do the calculation. 2 times 3 factorial, that's 2 times 6. So we have 12. And then plus 2 times 1 times 2 factorial, that's 2 times 2. So that's 4. And then we need to multiply 2 from outside. Then this equals 16. times 2 equals 32. Therefore, D is our choice, 32. And before we end this video, I want to make a couple of comments. One is what we already made in the middle of our analysis is in this step, you can actually find many patterns that I do recommend you to do the exercise and try different patterns. And you'll find that many of them are very legitimate and are actually pretty cool. And the second statement I want to make is about the way that we do the casework. For example, in the first step, we find this pattern. And I find this to be one of the few ways that we can solve the problem in a reasonable amount of time. And certainly, if you have 10 or 15 minutes to solve this problem, you can take a different approach. For example, you can use the exclusive and inclusive principle. And but that requires a lot of time. You have to be careful and to count the 3 consecutive increasing numbers, or 4 consecutive increasing numbers, or 5, and then deduct the duplicates. And at the same time, you shall also consider the decreasing scenario, right? So my estimate is that if you choose that approach, it will probably take you a while, 7 to 10 minutes. Therefore, I don't recommend that approach for this problem. Alright, if you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.